Welcome back, Exoplanet Detectives. To continue this phase of your investigation, you need to have with you the Cheops light curve data and the best fit results. Now it's time to investigate the size of the exoplanet.
Exoplanets come in lots of different sizes.
They can be as small as our moon, as big as Jupiter, or even bigger.
But how do you find the size of an exoplanet?
I'll be right back. Max, I think we need your help again.
Hey Ali, no problem. Let's have a look. Determining the size of an exoplanet is simple if we use the transit photometry method. This method is used by the Cheops satellite, with which I'm currently working at ESA. When using this method, the telescope measures the amount of starlight over a time period. When using the transit photometry method, we do not directly detect the exoplanet, except for very specific cases. Instead, we measure the amount of starlight that the exoplanet is blocking when it passes between the star and the telescope. The amount of starlight that the exoplanet blocks is normally referred to as the transit's depth, and this value is proportional to the exoplanet's projected area. Scientists fit models to the data to attempt to detect variations of the starlight that could be caused by an exoplanet. Are you ready to determine the size of Cal3b?
Yep. Let's analyse the light curve fit. Pause the video now to try to figure out by yourself how to measure the size of your exoplanet. When you're ready to see an example, press play again, and I'll see you back at the office. Bye, Max. I think I have all the information needed to determine the radius of Cal3b. By analysing the transit light curve, I have measured the transit depth to be approximately 0.9%. I also found out the size of the star, Cal3, on the case file. The radius of the star is 1.7 times the radius of the Sun. Using the equation, I have calculated that the radius of Cal3b is 0.161 times the radius of the Sun. That seems pretty big for a planet. How much would that be in comparison to the Earth's radius? Converting the radius of the Sun into Earth radii units, we find that the radius of Cal3b is around 17.5 times the radius of the Earth.
Our estimation of the planet's size is spot on and very close to the best fit model output. This planet is very big, even bigger than Jupiter. Have you noticed the value for its orbital period? It is only 2.7 days, much shorter than the 87.97 days of Mercury. And Mercury is the planet in our solar system with the shortest orbital period. Let's investigate this mystery in the next step.